Good morning, students. This is Anjali, Assistant Professor, Department of CAC, AML, IARE, Hyderabad. Today's our topic name is Definition and Terminology on Data Pre-Processing and Feature Selection. In previous class, we have seen that definition and terminology on flavors of data. Like in that particular session, we have seen about the data, different levels of the data science and so on. But now we will see the data pre-processing and the feature selection. Now, first one is that what is meant by data cleaning. Everybody know about the data. Data means just figures, tables, information, all are the data. Now, what is meant by the data cleaning? Data cleaning is the process of fixing or removing incorrect, corrupted, incorrectly formatted, duplicate or incomplete data within a data set. When combining multiple data sources, there are many opportunities for data to be duplicated or mislabeled. Data cleaning is just a process for the fixing or removing the incorrect, corrupted, incorrectly formatted, duplicate data, incomplete data within the data set. So here, whenever you will access the data, you are collecting the data, at that time what will happen? So many things will come with that data. Sometimes it will come duplicate data also. It will collect some errors also. So at that time, you have to process on it. You can't use that after collecting only that data for particular project or for particular research. So for that, you have to clean your data. And for cleaning purpose, that means what you will do, what you will clean. Just you will remove your duplicate data, you will remove the incomplete data, or you have to correct your incorrect data. You have to remove corrupted data. So every time we have to format our data. We have to clean our data. Why we need to clean our data? Because if you will use uncleaning data as it is, that will be not useful for the people, it will be not useful for the users also. So when you will combine multiple data resources, there are many opportunities, there will be many chances of the duplicacy of data, mislabeling of the data. So that's why there is a need of the data cleaning. And for how you will fix that data, how you will clean that data. You can use the removal of the unwanted observation. You can fix structural errors. You can manage the unwanted outliers. You can handle the missing of the data. So after collecting or at the time of collecting data, there are so many chances of occurring the unwanted observations, unstructured data, or sometimes structural errors also can come. Sometimes unwanted outliers can recognize, and sometimes your data also can miss. So everything we have to manage by using the data cleaning process. Now, why we need the data cleaning important in the data science? Actually, the main aim of the data cleaning is to keep as much of the data set intact as possible. And if you will use the data cleaning process, it helps improve the reliability of your insights. Actually, data cleaning is not only important for data analysis, it is also important for general business, housekeeping or data governance also. So data cleaning is used for everything. It is used for data analysis also. It is used in various businesses also. And the goal of the data cleaning is to prepare the data for analysis and ensure that insights derived from it are accurate and reliable. So main goal of the data cleaning is to prepare data for analyzing purpose, then for ensuring purpose. For everything you have to use the data cleaning. Now next one is data integration. What is meant by data integration? Data integration is common industry term referring to the requirement to combine data from multiple separate business systems into a single unified view, often called a single view of the truth. Data integration is just common term which is used to refer the requirement for combining data from multiple separate businesses. That means you are collecting data from different sources, and that collected data you are keeping in one unified view, in the single view. That is the data integration. And the unified view is typically stored in the central data repository that is known as the data warehouse. So that unified view is just, we can say, the central data repository. Now that means, for example, you have collected the data from one source, from second source, from third source. Now you have collected this data and you are keeping in one source. So this is one single unified view. Unified view. Here you are keeping the data. This is data integration. Here also see, there are different data source 1, data source 2, data source 3, data source 4. And in data source 4, after collecting the data, after accessing data, you are keeping the data. You are using the data integration technique, and after using data integration technique, you are keeping your data in the single unified view. This is the just systematic view of data integration process. Now, data integration process. Data integration of data is important because it not only gives the coherent view of the fragmented data, it also ensures the consistency of the data. If you will use the integration technique, so at that time, it will not give only the fragmented data. It will ensure about the consistency of the data. It will give the guarantee of the data. This allows the data mining software to extract the valuable information, which in turn encourages managers and executives to take rational measures to develop the business. So here, data mining software are using for the extracting of valuable information, and they can encourage managers and some executives for taking rational measures for developing the business. So extract, convert and load. So this is the process: extract, convert and load. Here dataset copies are compiled, then harmonized and then loaded into the data warehouse or archived from various sources. That means what will happen? You are collecting the data from different sources. Then you are converting, you are compiling that data, you are harmonizing that data, and then after that you are loading that data into the data warehouse. Then next one is that extract, install and the transformation. Extract, install and the transformation. Now here what will happen? Your data is loaded. Actually, data is loaded into big data system and converted for specific analytics use at a later time. Here what will happen? Whatever you have the data, you have to load into the big data system, and after that you have to convert into the specific analytics which will be used after some time. Now change the data capture. In this, you have to identify in real-time information changes in databases and applies them to a data warehouse or the other repository. Here you have to identify the real-time information changes, and then you have to apply some repository process. Next one is the data replication. Data is replicated to other databases in one database to keep the information synchronized of operational and backup uses. Here, data is replicated to other databases in one database for keeping the information synchronized format. And that synchronized format of data we can use for the operational and backup uses. Now, next one is data reduction and its importance. Data reduction is the process of reducing the amount of capacity required to store data. It is just a process of reducing the amount of data. Now, data reduction can increase storage efficiency and reduce the cost. Storage vendors will often describe storage capacity in terms of raw capacity and effective capacity, which refers to data after the reduction. So here data reduction is just a process of reducing the amount of the capacity and the reduction process can increase the storage efficiency. It can reduce the cost of the particular data set. Then vendors can describe the storage capacity in terms of the raw capacity, effective capacity. Here are some strategies also. So there are different strategies in the statistic, or we can say in the data reduction. That one, dimensionality reduction. So you are reducing the data according to the dimension. Then attribute subset selection. You have to select some attributes. Then next one is that discretization and concept hierarchy generation. Then numerosity reductions. And the last one is the data cube aggregation. So these are the data reduction and the strategies. By using these strategies, you can reduce your data. Now, data transformation. The data transformation is the process of converting data from one format such as database file, XML document or Excel spreadsheet into the another. Data transformation is process of converting data from one format to another. Like we can say your database is in XML format, Excel format, then you can change into Word format, you can change into MS Access format. So you are converting your data in different format. So transformations typically involve converting raw data source into a cleansed, validated and ready to use format. So generally transformations will involve some converting raw data source. That means your data will be in clean format, validated format, and that data we can use very easily. Which steps you have to follow at the time of data transformation? So there are 4 steps, and every time you have to follow these 4 steps. What are the 4 steps? First one is data interpretation. You have to interpret your data. Then step 2 is that pre-translation data quality check. After interpreting, you have to check the quality of that data. Then step 3, data translation. After checking the quality, you have to translate your data into the different format. And step 4 is that post-translation data quality check. So these are the 4 steps you have to use while data transformation. Now there are different techniques of the data transformation. For example, one, data smoothing, data generalization, data discretization, attribute construction, data aggregation, and the data normalization. These are the techniques of the data transformation. Now next one is data discretization. What is meant by data discretization? Data discretization is defined as a process of converting continuous data attribute values into a finite set of intervals and associating with each interval some specific data value. Just data discretization is process for converting the continuous data attribute into the finite set of the intervals, and those data will associate with each interval for the specific data value. Now this continuous data is converting into the discrete value by using the discretization. Next one is feature generation. The feature generation is also known as feature construction, feature extraction, or feature engineering. Is the process of transforming features into new features that better relate to the target. So feature generation is the just process of transferring your features into the new feature. That new features will be useful for getting a new target. This can involve mapping a feature into new feature using function like log, or creating new feature from one or multiple features using multiplication or addition. So this can involve some mapping of feature, and this mapping feature into new feature. They can use some log, creating new feature from one or multiple features using the multiplication addition. So the feature generation is of paramount importance in any pattern recognition task. If you want to recognize your pattern, so at that time we can use the feature generation, and the goal is to discover compact and informative representations of the obtained data. Main goal of the feature generation is to discover your compact, or to discover the informative representations whatever you got the data. Then feature selection. The feature selection is the process of isolating the most consistent, non-redundant and relevant features to use the model construction. And the methodically reducing the size of data sets is important as the size and the variety of data sets continue to grow. So feature selection is method of the isolating the most consistent, non-redundant, relevant features to use in model construction. And the feature selections generally have two types again, supervised and unsupervised. And supervised method will contain intrinsic, wrapper method and the filter method. Now, how are filter methods and wrapper methods of feature selection are the difference? Actually, wrapper methods measure the usefulness of the features based on the classifier performance. And in contrast, filter methods pick up the intrinsic properties of the feature, that is relevance of the feature, measured via univariate statistic instead of cross-validation performance. So here, generally wrapper methods will use the usefulness of the feature, and that will be totally based on your classifier performance. And the filter method will use the intrinsic properties of the features, and that means the features which are measured via univariate statistic. They will not use any cross validation performance, they will use only the univariate statistic. Now wrapper method in feature selection. In wrapper method, the feature selection process is based on specific machine learning algorithm that we are trying to fit on a given data set. Now in wrapper method, what you will do, you have to use feature selection process, and this feature selection process is totally based on your machine learning algorithm. And here we will use we will try to fit our data into the particular given data set, and it follows a greedy search approach by evaluating all the possible combinations of features against the evaluation criterion. Here we can use the greedy search approach, greedy algorithm, and the wrapper method searches for an optimal feature subset tailored to a particular algorithm and a domain. Now we compare the wrapper approach to induction without feature subset selection to relieve a filter approach to feature subset selection. So here wrapper method will search only for optimal feature subset which are tailored to a particular algorithm and a domain. And wrapper approach will compare. Actually here we can compare our wrapper approach for inducting without feature subset selection and to relieve the filter approach to feature subset selection. Now here we are using the wrapper feature selector. There is happening some search. For searching, we are using some feature subset, that one S1 and S2, and then after using the classification model, we are sending some output to that machine, to that data set, and here is happening some classification performance. And after that, optimal feature set is there. We are using the optimal feature set, and then after that we are getting the output in the form of the classification model. That means here we have to use the some complete feature sets. Then we have to use the wrapper feature selector. That means we have to search by using this feature subset. Then you have to use the classification model, and after using the classification model, there will be some classification performance and you will get the some optimal feature set output. Now, decision tree algorithm. A decision tree is a non-parametric supervised learning algorithm which is utilized for both classification and the regression task. It has a hierarchical tree structure which consists of a root node, branches, internal nodes and the leaf nodes. So here decision tree is just non-parametric supervised learning algorithm, and here we can use both the classification and the regression task also. Generally that decision tree algorithm is a hierarchical structure. It will contain some tree structure, and that tree structure will available some root nodes, internal nodes, leaf nodes, and it will contain some branches also. Now we will take one of the example. Our root node is, this is root node. These are the branches. So root node is saying that, is it a house? It's a question. You have only two choices, yes or no. If your answer is yes, then there is built before 1920. If your answer is no, then more than 4 bedrooms. Now here two questions are arised. One built before 1920 and built more than 4 bedroom. Then again, if it's built before 1920, again if there are two chances, yes or no. If it's yes, then what is the cost? $220,000. And if it's no, then what is the cost? $480,000. And if it has more than 4 bedrooms, again there are two chances of the answers. One is a yes and another one is a no. And if yes, then what is the cost? $340,000, and if your answer is no, then $180,000. So this is the decision tree. You are deciding on the basis of some questions. So if your answer is yes, no, then whatever it is, then that means your tree is increasing day by day. This is the decision tree. You are taking a decision on the basis of that tree, on the basis of that branches, on the basis of that questions. Next, there are some advantages of decision tree. Actually, decision tree comes with more than one perk. Actually, it enables you to follow a decision process effectively. You know that if you have kept any data in the form of the tree, then automatically you will get the information very effectively, and immediately you will get the information what data is available, what data are available in that particular tree. Then it helps you deal with a wide range of the option. Definitely, decision tree will provide so many options. So on that basis, you can take any decision. You can add new scenarios easily. Definitely, decision tree is there. So definitely, if you want, you can add new scenario. If you want, you can remove some scenarios. It doesn't require large amount of hard or factual data for a decision process. Hard data is information such as number or fact that can be proven. And contrary, soft data refers information that is difficult to measure. For example, people's opinions or feelings. So actually this decision tree is not containing any hard or factual data. What is meant by the hard data? Hard data means numbers of facts where we need to prove. And soft data means just information but which is very difficult to measure. Like we can say the opinion, people's opinion. We can't measure, we can't count the people's opinion. Feelings, we can't count. We can't measure the feelings. So, it helps you with the best, worst and expected result for various scenarios. There, obviously, decision tree can be in various scenarios and every scenario has different trees. Sometimes you will get best result, sometimes you will get the worst result and sometimes you will get the expected result as you want. So these are the advantages of the decision tree. Now random forest. The random forest is a classifier that contains a number of decision trees on various subsets of given data sets and take the average to improve the predictive accuracy of the data set. Random forest is a classifier. It will contain the so many number of trees. It will contain various subsets of the data set. It can take the average of the data and with that it can improve the accuracy of the data set. Instead of relying on one decision tree, the random forest takes the prediction from each tree and based on the majority votes of predictions and it predicts the final output. The greater number of trees in the forest leads to higher accuracy and prevents the problem of the overfitting. So here, random forest can take so many predictions. So many predictions means random forest will contain so many trees. They are containing so many decision trees. And on that basis of the trees, we are taking the some decisions. We are finding out the some outputs. We are finding out the some predictions. And after predictions from every tree, we are getting the final output. So definitely that final output is very important for the random forest. And if you will use the so much number of trees in the forest, then definitely it can improve the accuracy of the data. It can avoid the problem of the overfitting. Now there are some assumptions for the random forest. Since the random forest combines multiple trees to predict the class of the data set, it is possible that some decision trees may predict the correct output while others may not. Actually, random forest combines some multiple trees for predicting the class of the data set. And sometimes it's possible also that some decision tree may predict the correct output and sometimes may not. But together, all the trees predict the correct output. Therefore, below are two assumptions for better random forest classifier. Sometimes you will get correct output, sometimes you will not get the correct output. But if you will keep all the decision tree together, so at that time definitely you can predict the correct output. So for that purpose, you have to follow two assumptions in the random forest classifier. First assumption is that there should be some actual values in the feature variable of the data set so that the classifier can predict accurate result rather than guessed result. First assumption is that there should be some actual values in feature variable, and because of that you can predict the accurate results. You will not guess any result. Here you will get the accurate result, particular result. The predictions from each tree must have very low correlation. There should not be so many correlations between the variable, between the data. There should be only, there should be low correlation between the variables. Now for example, suppose there is a data set that contains multiple fruit images. So this data set is given the random forest classifier. The dataset is divided into subsets and given each decision tree. And during training phase, each decision tree produces prediction result, and when a new data point occurs based on the majority of the results, and the random forest classifier predicts the final decision. Now, there are instances are containing so many fruits: tree 1, tree 2, tree n. Tree 1 class A and tree n class B. That means we are going according to the majority voting, and here majority is for the apple. So final class, your final result is that apple. So now here there is again one question on that basis, that is random forest better than the decision tree? With that said, random forests are a strong modeling technique and much more robust than a single decision tree. They aggregate may decision trees to limit overfitting as well as error due to bias, and therefore yield useful result. So generally random forests are very strong modeling technique as compared to your decision tree, and they can aggregate also many decision trees for the overfitting also. So these are the references, you can go through this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.